In our previous video, we have talked about DFS, and in this video, we'll try to convert that into code. So this is code, as you can see, this is the previous code, and I'm going to use this input file to take input. Now, one thing that I've changed here is I've declared node and edge as global variable, and the rest of this code just looks the same. Now, if you can recall from the previous video that the color of a node used to vary from time to time. Maybe at first the color of this node 1 is gray and then it's black, so that's how I used to change the colors. Now in the program we are going to do the same work. I'm going to define color variables, so I'll just define white as value 1, and I'll define another color, let's say it's gray, as 2, and define, let's say, black as 3. Now to maintain the colors of all the nodes, I'll need an array, so I'll take an integer array in color, and let's assign 100 as its size. Now let me explain to you how this color array and all these color variables are going to work in code. So initially I have defined all the colors. So the value of white is 1, the value of gray is 2, and the value of black is 3. And the other thing that I have done is taken an array for maintaining colors of all the nodes. Now let's assume at some point, let's say node 1, at some point the color of node 1 becomes gray. So that means I will go to color array, and as I'm working with node 1, as the color of node 1 is gray, I will just write gray in the index 1. And what does gray stand for? Gray actually stands for 2. So basically I will be assigning 2 or gray to this variable. Now the same way, if the color of this node 4 becomes gray, I will repeat the same steps. I will go to the color array and I will go to the 4th index of this color array and assign gray to this index, and in this case gray means 2, so basically I am assigning 2 to this index. Now that's how the color array is going to function. Now let's create a function and name the function DFS. Now let's assume that if I call this DFS function, it will apply DFS on all the nodes, and let's call it from the main function. Now I'll make another function, and this time let's name it DFS visit. Now this function takes an integer as parameter. Now what does this function do? We'll talk about it later. Now if you can remember from the previous video, initially all the nodes were marked with color white. Therefore I'll come to the function and assign white to all the nodes. Now the value of white has been defined earlier, and therefore this statement is going to work correctly. Now if you can remember from the last video that we faced a problem in our last video. If we start DFS on this node, let's say, then all the nodes, those are directly or indirectly connected to it, will be visited, but then 5 and 6 are not going to get visited. So what we needed to do was try to implement DFS on all the nodes we have got in the graph, but there was a condition, and that was we could only start DFS on those nodes those are marked as white. So we started by applying DFS on node 0, and once we applied DFS on node 0, all the nodes those are connected to node 0 were marked with color black, and therefore we could not apply DFS on the other nodes like 1, 2, 3 and 4. Later we finally went to node 5 and tried to apply DFS. Node 5 was colored white, therefore we applied DFS on node 5. So the main point is that I'll try to apply DFS on all the nodes those are available. Now out of those nodes, the nodes with color whites are the nodes where I'm going to apply DFS, and the nodes with colors other than white are not eligible for DFS. Now to achieve this task, I'm going to take a for loop int I equals 0, I is less than node plus plus I. Now if I find a node with color white, then I'm going to apply DFS on that particular node. So it will look something like this. If color of I is equal to white, it means that if the color of the ith node is white, or if the ith node is marked as white, then I'll be able to apply DFS on that particular node or on the ith node. Now how to start DFS on a particular node? Let's say DFS visit does that work for us. When we call DFS visit and pass any parameter or any node, then DFS visit is going to apply DFS on that particular node, on the node that we are passing to that DFS visit function. Therefore, I'll just say DFS visit and I'll pass I as the parameter. Therefore, DFS visit will start DFS on that ith node. So if the color of the ith node is white, then I'll start DFS on the ith node. Now it's showing me error because DFS visit function is declared after DFS. So let me drag and drop it before the DFS function. Now let's say in a situation the value of I becomes 0. So we'll be calling DFS I. So we'll be calling DFS 0. Now the value of I and value of X in this case is going to be 0. So basically we'll start working with the node 0. Now as we'll start working with the node 0, we'll have to mark this node with color gray. That's what we have done previously, and we are going to do the same thing in our function as well. We will mark the 0th node with color 0. In this case the node 0 is basically node X, so we'll change the color of node X to gray. So we'll just write color of X is equal to gray. Now afterwards we would have to perform some task with this node. Maybe we would go to node 1 or go to node 2 from this node, but once we are done working with this node 0, we would mark that node with color black. So let's assume that this is the place where we perform all our tasks. Now once we are done with all the works, we'll mark the node X with color black. Now we just need to write the code for the task in between. Now let's assume that the value of X in this case is 0. So we are going to work with this node 0. In this case node X is basically node 0. Now what exactly did we do in this node? We would go to node 1 from this node, or we would go, let's say we would go to node 2 from this node. So basically we could go either to node 1 or to node 2, because node 1 and node 2 are the neighbors of node 0, and therefore we could go there. So basically from node 0 or node X, what we need to do is go to another neighbor node. So all we need to now do is find out the neighbors of node X or find out the neighbors of node 0, and then if the neighbor is not visited, if the neighbor is marked as white, then we would visit that node or apply DFS on that particular node. Now hopefully you remember from the previous videos how to find out the neighbors of a given node. Now to find out neighbors of a node, we'll have to use a for loop. So for I equals 0, I is less than node plus plus I. Now in this case I'll have to find out the neighbor of variable X, and therefore I need to check adj of X and I. adj of X and I. If adj of X and I is 1, then that means then I is a neighbor of the variable X, of the node X. Now hopefully you can recall how to find out the neighbors from the previous video. Now if you do not know how to find out neighbors, you can watch this video. Link of this video is given below in the description box. Anyway, if the value of adj of xi is 1, that means it's marked as white. That means we'll have to go to the ith node, but before we go and visit the ith node, we'll have to check if that node is already visited or not. So basically we'll have to check whether the ith node, whether the color of the ith node is white or not. If the color of the ith node is white, that means we can go and visit that node, otherwise we cannot visit that node. Therefore we need to check first. If color of I is equal to white, that means we can visit that particular node. Now how do we visit a particular node? We simply use DFS visit to visit that node. So therefore DFS visit is going to call itself. We'll just call DFS visit and pass I as the parameter. So this is how we are going to visit the node I, and this completes our DFS visit function. So that's how we implement DFS.